So we're going to go through question 2 now. So question 2 is quite a lot different after question 1, but it's still worth 6 marks, and you've still got to think about how to plan your answer. And we're still going to go about it in the same way, actually. So question 2. Experiments can be carried out to find out the volume of oxygen in a given volume of air, because air contains oxygen. So you should be thinking now, well, how much oxygen is in air, because that's the kind of thing that it's going to start talking about. We know that it's 21%. When hot, copper reacts with oxygen. When hot, copper reacts with oxygen. So when you heat copper, it will react with oxygen. In one experiment, the following apparatus is used. At the start of the experiment, 100 centimetre cubed of the air is in gas syringe A. So before you've started heating the copper, you've got 100 centimetre cubed of air in here. Okay? None in this one. The air is passed backwards and forwards over the heated copper. So think about how you do that. You'd have to push the plunger there to get it one way, and this one would pop out, and then you push it this way to get it the other way, and it passes the air over the copper. Describe how. I'm going to underline how. I'm thinking about what the question's asking me to do. It's asking me to describe how this apparatus is used. So what do we do when we're using it to show that 100 centimetres of air contains 21 centimetres cubed of oxygen? Okay, so it's not like here we've got advantages and disadvantages. It's more of a big long description. But what I would split this into, first of all, literally how it is used, what you would physically do, and then the second half I would think, how am I going to calculate that 21 centimetres cubed of oxygen was used? Practically, what do I have to do at the end of the experiment before I get my results? And try and think about this in as much detail as possible. Okay, so I want you to now think about. Well, first of all, let's get started about, just in case you're not quite sure on what's happening here. At any point, pause me and have a go at the question. So what's happening with here is that the copper is reacting with the O2 in the air. Okay. Now, when these two things react, we're going to make copper oxide. Okay. Now, copper oxide is a solid. So particles in a solid, very close together, takes up hardly any volume compared to oxygen, which is a gas. So the particles are very, very spread out. So this is going to have lots of volume. When we've taken it to make a copper oxide solid, and we've got rid of a bit of copper solid anyway, the volume of this is nothing compared to the volume of this. So this volume here is going to get reduced as we go, as the oxygen gets taken out of the air and into the copper oxide, which is a solid. Okay, so what we're going to have to do is heat this and carry on passing the air back and forward over the copper, so on the surface it reacts to form copper oxide until all of the oxygen has made copper oxide. So then you've got to think, when we've all of the oxygen making copper oxide, at the end of the day there, how are we going to know that's happened? We have a little think to yourself, how are you going to know that's happened? How are you going to know that you expect your reaction's finished? How are you going to find out that 21 centimetre cubed of air is there? Remember, this syringe will have readings on it. So at the start, it says maybe 20, 40, 60, 80, 100 millilitres at the start. How are we going to know that 21 centimetre cubed has been left? What are you going to have to do at the end of the experiment before you take that measurement? Because remember, you've heated a lot of things up, so that's one of the points as well. And then maybe a little example of the calculation at the end to get the 21. Okay, so I want you to pause me now and have a go at the question, and then we'll go through the mark scheme now. Good. So here's the mark scheme. So hopefully you've had a go at this question now. What they're looking for, the points they're looking for, and again we're going to look at underneath kind of the categories as well. But this one, with this few points, there's only 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So you're looking, if you get most of those points, you're going to be getting somewhere towards 6 marks if you put them nicely together. Okay, push and pull syringes to move the air. Did you get that one? The volume of air in the syringes decrease. Have you at some point said that the volume of air is getting less because the oxygen is getting removed? Oxygen removed from the air. Copper reacts with the oxygen. Okay, you can use the word joins instead. copper oxide is formed. You continue until there's no further change, and then remember, this one's easy to forget. You've got to remember the apparatus. This apparatus needs to cool because hot gases take up loads of space, and the cold gases don't take up as much space at all. If you give a little information about the calculation to get the final reading on the syringe, that's another point that they're going to give you credit for. And then if you've said that and explained because this oxygen has been reacted with numbers, then that's 2 points just for kind of getting into the nitty-gritty numbers there. Okay, so just have a look at that tick, count up your ticks, think how many you're getting, and then we're going to see how you're going to find out how many marks you've actually got, because the tick isn't worth a mark. So you're looking, if it's a limited description, you've just said what happens, you've missed out points from above, maybe you've got 2-3 points, so you've kind of got the idea you might be able to get 1 or 2 marks, but you've missed out, how the calculations are done at all, you've missed out the fact that what reaction has happened, you've just kind of said how to do it a little bit. Here we're starting to get a little bit more depth. Look at the examples. Hot copper reacts with oxygen to produce copper oxide, so the word kind of describing the equation there. Copper oxide is formed as the volume of air decreases. So this example here is quite good quality, but it's only worth 3 or 4 marks. So you're looking for this, but now for 5 or 6 marks, you're looking for this, but kind of detailed description. So you're looking at for this kind of thing, but for all the different points need to be in that kind of quality. So really good, coherent argument, uses the calculations at the end to tell them if you've got 79 centimetres cubed left, take that away from 100, you're going to have 21 centimetre cubed. That must have been the oxygen that was there at the start and not there at the finish. Okay? So have a little go, again, mark it, think what mark you get, compare it with what your teacher thinks you should get, and that'll give you a good idea of whether you're marking this thing the right or the wrong. Okay, good stuff. There's another 4 questions as well. So have a go at the other 4 questions, the mark themes are there, do the same process for these. These are really vital because there's 2 of these in every exam around. That's 12 marks out of 60 in every exam. So what's that, 20% of your marks are in these kind of questions. If you don't know what to do with them, then that's a too big amount of your question to be throwing away. So really make sure that you're comfortable with these to at least get up to the 4 or 5 mark so that you're not going to throw away too many marks.